section 2.3. We've already talked about the product rule. We've already talked about the quotient rule. We've already talked about some ways of simplifying expressions.
Can we talk about those lights?
Yes. Someone grab a light, please.
Grab a light.
So we are now down to, we already went through that example. I believe we are right here. Yes. More trig functions, derivatives. I have given you guys the derivative of the sine function. I've given you the derivative of the cosine function. There's 4 more. What is the derivative of the tangent? What is the derivative of the cotangent, secant, and cosecant? And I'm thinking right now, I am pretty sure that I will provide you with these things on test day, okay? So make sure you have these things in your notes, easily accessible, so that you can just refer to them when you need to, when you're working on your assignments. And then on the test day, I will actually give you a sheet with those things on it, okay?
Okay.
The derivative of the tangent of x is secant squared of x. The derivative of cotangent of x is equal to negative cosecant squared of x, or squared x. F of x, if it's the secant of x, the derivative is secant tangent. If it's cosecant, it's negative cosecant cotangent.
Oh no. Ooh.
And you would see that, you guys know tangent. Tangent means sine divided by, I was hoping someone would recall, sine divided by cosine. Well, sine divided by cosine is a quotient. It's a division problem. So you could go through the quotient rule, and when you go through all the steps of the quotient rule, it would simplify. We're not going to go through all those steps, but it would simplify to give you secant squared of x. Secant squared of x. Those pink sheets that I gave you at the beginning of the year might be helpful right now, especially not the one that has the unit circle on it. That's the one that's going to be helpful. Okay? Is that the darker purple one? The darker purple one is probably going to be helpful. Yes, you are allowed to use those on the test too. Okay?
He's making fun of you.
Oh, her paper's pink?
No, the paper you're talking about is pink.
Dark pink.
You said
You said purple.
I said purple?
Like
I did?
Yeah.
Great.
Yeah. More than one.
You know what that's called? It's called, I don't get enough sleep.
Getting
No.
I'm
It's
just
not.
That's what you're gonna say.
She is.
Okay. Example. Can I keep going?
Yeah.
Okay, example. F of x is equal to x minus the tangent of x. Yes.
Hold up, please.
I kind of want to refer back to these, but you know what? I will scroll up a little bit. Is that good?
That's good.
Okay. You know what, you guys? I'm going to be honest. I don't have them memorized, so I'm going to need your help. I don't know if I ever will. I don't know if I have enough brain cells to.
One.
What is the derivative of x?
One.
Derivative of x is 1. So we have 1. We have 1. That's weird. Is it white?
It's white.
Purple.
Yeah, purple.
White changes on the
Gives me interesting.
Oh.
Dang it.
That's right. All right, 1. Derivative of x is 1. What is the derivative of the tangent of x?
Secant
It is secant squared of x.
What if
It's minus the secant squared of x. So now what I need you guys to do is get out your pink papers. And on your pink papers, is there something on your pink papers that tells you 1 minus the secant squared of x is something? And when I say that, I am talking about like midway through on the left-hand column, you've got some Pythagorean theorem identities. Does it say anything about 1 minus the secant squared of x being something?
No.
It does. What does it say? There is an identity that says this. 1 plus the tangent squared of x is equal to the secant squared of x. So if I take this secant squared of x and I subtract it from the right hand side, and then I subtract it from the left hand side, I would be left with 1 minus the secant squared of x plus the tangent squared of x. Did you follow what I just did?
No.
This is an identity. 1 plus the tangent squared of x is an identity. Are you okay? Did you locate that on your paper?
1 plus the tan of x.
1 plus the tan of x, tan squared of x is equal to the secant squared of x. And I know that if I can take secant squared of x and move it to the other side, it will be 1 minus the secant squared of x. Does that make sense?
Yeah.
But the problem is when I move it over to the other side, I still have this plus tangent squared of x added on. So I need to get rid of that. I need to move it to the other side. Because right now, this is equal to 0. So I subtract the tangent squared of x from each side, and it's going to leave me with 1 minus the secant squared of x is equal to, what is 0 minus the tangent squared of x? Negative tangent squared of x. So f of x is equal to, the derivative of f of x is 1 minus secant squared of x, which is also equivalent to what? Negative tan squared of x. So, when you look at this, 1 minus secant squared of x, you think, okay, probably done, right? At first thought, you'd probably think that. Look at your identities. See if there's some identity that you can get out of a 1 and a secant squared. See if there's some way that you can make that happen. I don't think that that's too difficult to see. If you take this secant squared of x and you just move it to the other side, it becomes 1 minus, but then you got to move the tangent squared of x to the other side too. I don't think that's too tricky. Second example.
I have a question.
Yeah.
Why can't you just replace the secant squared x with the 1 plus, was it plus tan squared x?
You could. That's a great point. This is what we ended up with. You had 1 minus the secant squared of x. Well, the secant squared of x is equal to 1 plus the tangent squared of x. So this is really equivalent to 1 minus 1 plus the tangent squared of x.
So why can't we just do that?
You can. There's more than one way. Certainly. I'm just going to distribute the negative in. When you distribute the negative in, you're going to have 1 minus 1 minus the tangent squared of x. Oh, you didn't see that I was going to take it a step further. Those two cancel out, and you're left with negative tangent squared of x, which is what I got when I did it the other way too. That makes more sense to you? Okay.
How did you do the second one?
The second way, well, Sydney looked at this and said, 1 plus the tangent squared of x is equal to the secant squared of x. This is the identity that's on your paper. And she saw this, secant squared of x, in our derivative. So she said, well, why can't I just take this secant squared of x and replace it with 1 plus the tangent squared of x?
Where did you do that?
The paper. Yeah, from the paper. All right. Okay. So you really have 1 minus, she replaced this with 1 plus the tangent squared of x. So she said, okay, well 1 minus the secant squared of x really is 1 minus 1 plus the tangent squared of x. Then you distribute your negative in, and you end up with negative tangent squared of x.
That's a lot easier.
That's a lot easier. Yep. See, and that's one of maybe the only beautiful thing about math is that there's more than one way to get the same answer. Okay. Do I need to re-explain?
Nope.
Ready for the next one?
Yep.
I think the next one is maybe it's nicer. I don't know. I don't remember. All right. And this is where I need you guys to help me because I honestly don't have the derivatives memorized. What am I going to use? Product rule, because it's x times the secant of x. So the product rule says that I have to take the first polynomial, x.
Which one do we use in example one?
What did you say?
Why don't we use the product in the?
Well, the first example was 1 minus something
Instead of times.
instead of multiplying two things.
Oh, yeah.
Okay, so you can't use, hey girls, you're multiplying, you need to use the product rule. The product rule says you take the first polynomial, which is x, and you multiply it by the derivative of the second. What is the derivative of the secant of x?
Let's see.
Excuse me? So it's secant of x, tangent of x, all right, plus, now we take the second polynomial, which is the secant of x times the derivative of the first one. What is the derivative of x?
1.
It is 1, so you just have to multiply it by 1. That's really nice. So this then is equal to, well, the secant of x times 1 is the secant of x. What do these have in common? They both have a secant of x. So I'm going to take a secant of x out. And when I take a secant of x out of this, I factor this one out. All I have left is x, tan of x. And if I take it out of this, what am I left with? Plus 1. Yeah, don't forget that plus 1. Lots of you will divide that out and think it's all gone, but there's still a 1 there. That's it. That one wasn't so bad. What are we going to use in this one?
Quotient rule.
Quotient rule. It's dividing. So, Robbie, when you divide, what happened? What do you do on the top? In other words, in the quotient rule, you subtract. Okay, good. Just checking. Okay. All right, so we take the denominator, which is the sine of x, and we multiply it by the derivative of the numerator. What is the derivative of the 1 in the numerator?
0.
0. What is the, I'm going to ignore the negative sign here for a minute. What is the derivative of cosine of x? Negative sine of x. So we have actually the negative sine of x. What does that really mean? Positive sine of x. Ooh, look at that. Sine of x times sine of x. That's probably going to get us somewhere. All right. Minus. Now we take the numerator, which is 1 minus the cosine of x, and we have to multiply that by the derivative of the denominator, and the derivative of the denominator is the cosine of x. And this all has to be divided by the sine squared of x.
How did you make the second sign?
The second sine of x. This right here. Okay, the derivative of 1 on the numerator is 0. And then the derivative of cosine is negative sine. But we are subtracting negative sine of x, which made it a positive sine of x. All right, let's clean this up. So we have the sine of x times the sine of x. That is the sine squared of x. And then over here, what we need to do is distribute in the cosine of x. So we have minus the cosine of x. Minus the cosine of x. Now this negative with this negative is actually going to get me a positive cosine squared of x. to stop. You know what I did? Can you follow what I did? And then this all has to be divided by the sine squared of x. All right, now, look at your pink sheets again. I'm hoping that of all the trig identities that you guys learned last year, that the one that you remember the most is the sine squared of x plus the cosine squared of x is 1. Do you remember that?
No.
Look at your pink sheets. There's an identity that says the cosine sine squared of x plus the cosine squared of x is equal to 1. Well, I have this, the sine squared of x plus the cosine squared of x. So you really have 1 minus the cosine of x divided by the sine squared of x, or sine of x, parentheses, squared. You don't have to memorize. You don't have to do a lot of memorizing. You have to be able to apply. So, yes?
Could you cancel sine squared x?
We certainly could take this a step further. I am okay with this answer, but if you took this a step further, you would say that this is 1 over the sine squared of x minus the cosine of x over the sine squared of x.
At
The
Don't.
top?
no.
No, oh, you're just talking about the top.
No.
Oh, up here.
No.
Could I do what?
So the 2 sine squared of x out.
2 sine
Sine
squared of
squared
x.
of x.
Is there sine squared of x and sine squared of x? On top
There's
and
a
bottom.
sine squared of x.
Here and
on
here?
top. Yeah.
No, that's illegal.
Oh.
You can only do that. You can only do that if this term, and that term all contained what you're going to cancel it out with on the bottom.
That is illegal.
That is illegal. It is illegal. Yes. There was someone that did on their quiz too, and I can't remember. Was it you? You're going to admit to it? Did you do that? Okay. No, I was talking about Joey, but did you?
Yeah, I did
I
that.
did too.
Okay, yeah. Can't do that unless you can cancel it out with all the things on the top, all the terms on the top. Yeah. Now, if there were not plus and minus signs in between, if it was just the sine squared times the cosine squared, then you could do that. But these plus and minuses screw that up. Can't do that unless you can cancel it out with all three. Do you want me to keep going with this? Or
No.
is that-
No.
Okay.
Oh,
It's not really that bad.
Oh, well.
Alright, we'll just stop. We'll accept this. You guys can blame Tom for that.
No, you